So hi, my name's Mance Harmon. I'm a co-founder. There we go. I'm a co-founder and CEO of Swirlds. Swirlds is a technology company that is commercializing a fundamental breakthrough in computer science that we call the hash graph. The hash graph is not blockchain. It's an alternative to blockchain. It solves some of the fundamental problems associated with blockchain, both in terms of performance and security. The blockchain market is split really into two halves. There are the public networks, like you've heard about Bitcoin and Ethereum. They are extremely expensive in terms of the way that they secure the network. They're very inefficient. An average cost per transaction today to store something in, quote, the blockchain is about $2.50, which is really very limiting in terms of what you can do for use cases that can be used directly with the Bitcoin blockchain. The performance is terrible. If you want to think of the blockchain as a distributed database, it can only handle 3 to 4 transactions per second globally, which is as bad as it sounds, right? The alternative are the permissioned or private networks. A couple of years ago, the market realized the value of blockchain in terms of the security model that is being offered, but the performance constraints and the costs were prohibitive. And so what happened was the financial services industry decided, let's create private networks or permissioned networks. Let's take blockchain as a technology, an algorithm, a data structure and an algorithm out and replace it with an older category of technology. They're called leader-based algorithms. The security is worse, but the performance is better. In this case, the transactions are validated by, for example, if it were a consortium of banks, it would be validated by the banks themselves. And so there aren't unknown or untrusted, necessarily, participants in the network in some sense. The cost is better there. The cost is just the cost to run the software on a server, and you do that for the privilege of participating in the network. It can achieve about 1,000 transactions per second, but there's some serious security concerns. Are highly vulnerable to entire categories of attacks, including distributed denial of service attacks, and they're not fair. It's possible to actually bribe an individual to unfair advantage in ordering the transactions that are moving into the database. So the market today has been, do you go with the better security that costs more and performance is worse, or do you go with the worse security, lesser security, that's practically free and tops out at about 1,000 transactions per second? Those have been the two choices. Blockchain, IBM rather, this is a slide from IBM. IBM says for the permissioned network market, the holy grail of blockchain scalability is, what's important is this middle line. Seconds latency, and that refers to how long it takes the community to come to an agreement on the order of transactions. If I pay you a coin, how long do you have to wait before you know that that coin isn't going to disappear? That's the question that we're answering there. With Bitcoin blockchain, you have to wait an hour. So you're not going to go buy a cup of coffee necessarily with a Bitcoin, unless the merchant is willing to take on the risk that the coin might disappear. So seconds latency instead of an hour, 2,000 to 4,000 transactions per second on average. This is because that's what the payment processing networks process on average, like Visa, 2,000 transactions per second on average. And then 10,000 transactions per second peak throughput. The hash graph doesn't require the trade-off. Hashgraph actually processes hundreds of thousands of transactions per second. There's no proof of work or miners like there are in the public networks, and so the transaction cost is just the cost to process a transaction over the network, the bandwidth cost, or a little bit of CPU cost. It's a tiny, tiny fraction of a penny to actually process a transaction. It's patented. It's mathematically proven to have all of the properties that I'm describing. And when you look at the market, we have Bitcoin and Ethereum, the first two columns there, that represent the public networks, 7 transactions per second, 25 transactions per second, consensus latency. better security than the private networks. Hyperledger is an example of a platform that is addressing enterprise use cases on the permission side. Kadena is one of the faster alternatives that I've seen at 7,000 transactions per second. We have the best security in the market. We actually achieved the theoretical best that you can achieve. It's called asynchronous Byzantine fault tolerance. For 30 years, people have thought it's been impossible to achieve practically, and we actually achieved it. I mean it when I say it's a fundamental advance in computer science. It's all patented. So we have 3 awarded patents already, and we have multiple patents in the pipeline. So what do you do with it? And this is the answer. If you have this kind of technology, what's the killer application? In the world of blockchain, there's a big problem in that people estimate only 5,000, there are only 5,000 blockchain developers in the market. And there are companies everywhere that are trying to train developers on how to program in Solidity or these other scripting languages associated with blockchain. Everybody knows how to write SQL. It's the language of databases. It represents 95% of the database market. What we can do with our level of performance and our level of security is make it possible to create what I think of as a SQL proxy. So you have your application that is speaking SQL to our nodes, and then below our nodes is a SQL database. You give, each one of these regions represents a person in a consortium, a data center. So you take this stack, you give it away to everybody in your consortium, and your developers just use SQL instead of blockchain. In other words, we can take blockchain mainstream by eliminating the need to know anything at all about blockchain. You just use SQL, and you get the security benefits of blockchain. Gartner says that there are 4 fundamental different database use cases, and those first 4 there are how they break up the world of databases. What we've done is added a fundamentally new category of use case, that being the first multi-party SQL database. Multi-party is the key phrase here. The assumption has always been that there's one organization that's responsible for all the different nodes in your SQL cluster. And in our case, and in the blockchain case, you take these master database nodes and you give them away to your competitors, or people that maybe you don't even know or exist, that have a node in the network at all. They may be unknown to you. That set of security requirements that result from that is what blockchain is all about, and it's what we've solved with our technology. We achieve the best you can achieve in terms of security, and because of our performance, we can do multi-party databases with SQL. Whoops. So we have a consensus platform, just in the same way that the whole world, every company in the world today uses a web server to serve up web applications. We have a consensus server that serves up distributed applications. We have plugins, or we'll be building plugins for the major permission platforms like Hyperledger, EEA, Corda, Coco from Microsoft, others, that take out that consensus mechanism that's currently in place, replaces it with ours, and automatically upgrades the entire platform to achieve hundreds of thousands of transactions per second, and provides the best security in the market. And we're going to commercialize Hashgraph SQL, as I just mentioned. The go-to-market's pretty simple. We sell direct to large enterprise. We leverage the existing ecosystem of system integrators and VARs and global consultancies. We make it possible for them to sell our plugin and make margin on the consensus mechanism, which they cannot do today. Everything else in the market is open source. We're the only one that's proprietary, and we're proprietary because we're that good. If you are a generational leap beyond what's otherwise free, you don't make it open source, you patent it. And that's what we've done, and we're selling this proprietary technology. And we have OEM license agreements. So our first customer is the credit union industry. We won the business against IBM and Hyperledger. There is a new organization, CU Ledger, that is providing the platform for the 6,000 credit unions in North America, representing 105 million members. That will roll out in the new year. That's all built on top of us. We're working with one of the 2 global credit card companies. We have in the pipeline the biggest brands in terms of financial services and banking and investment banking in the world. We are based here in Dallas. We've done a seed round of financing. It was led by New Enterprise Associates, $3.5 million. We will be raising a Series A in the first half of next year. My partner and I have been doing this for a long time. We've been working together since '93. This is our third startup. We grew up in the Air Force, as it were. We taught computer science. We did research in machine learning. We've managed giant software programs for the Missile Defense Agency. We've been in the identity and access management space, sold a couple of companies to Fortune 5000 in private equity, and now we are going to have our own hype curve called the hash graph. That's the expectation. We have a Telegram channel. Over the past couple of weeks, it's grown from 350 users to over 3,000. I think we're approaching 4,000. And our SDK has been downloaded hundreds of times in the same period. That's it. Thank you. Questions? Yes?
Is blockchain going away then?
Blockchain will go away. And it's, and I know that's self-serving. It's actually a reality. Blockchain is inherently limited in terms of its architecture. It's very parallel in its processing. The whole industry recognizes that we have to move to a graph architecture, and there are a number of players out there that are already moving in that direction. We happen to be the one that has sort of solved the problem. So I'll make a very bold statement here. 100 years from now, there will be dozens of variants on the hash graph, but it will be on the hash graph, because you can't do better than what we've done in terms of performance and security. Other questions? Yes. Yes. Yeah, we're in the fortunate position of being able to match our customers' revenue model. And so really it's come down into two different strategies. One is transactional, always subscription. One is transactional, depending on the revenue model of the licensee. And the other one is a license that's similar to a database license, depending on the model of the customer. And so we can license on an annual basis this consensus server that I've described, based on the number of applications that are being served and the number of nodes and that sort of thing. Yes?
You mentioned the SDK. What platforms is the SDK?
The SDK is written entirely in Java, 100% Java. We make it possible to use any language that you want by creating a thin layer on top of that that serves up APIs, TCP/IP APIs, and then there are client libraries that can be used with Python or whatever you want to write the client application in to access those APIs. Okay, thank you.
Thank you very much.
I guess you answered the question that our panel had earlier, what's next? So we'll be looking for you. Okay.